SpaceX made landing orbital-class rocket boosters on drone ships look routine, but it was once pure science fiction. Before SpaceX, rockets were single-use and expensive, with valuable parts lost at sea or in the atmosphere. By perfecting drone ship landings, SpaceX slashed launch costs and made rapid reusability possible. Early attempts were fiery failures, but each one taught engineers how to refine guidance, grid fins, and engine control. Now, Falcon 9 boosters regularly land on ships like a shortfall of gravitas, a testament to years of persistence. Why land at sea? It's about efficiency. Returning to the launch site burns too much fuel, limiting payload. Ocean landings allow heavier satellites and deeper space missions while keeping people and property safe. This expertise is the foundation for Starship's next leap, landing even bigger rockets at sea. The principles, guidance, navigation, and control carry over just on a much larger scale. SpaceX isn't starting from scratch, they're building on a decade of hard-won experience. They know the challenges of marine recovery and the logistics of bringing massive rockets home. With this foundation, Starship's ocean landings are a matter of when, not if. Starship's ocean landings aren't just a theory, they're in SpaceX's official plans and FAA filings. These documents outline a future where Starship boosters and ships return to both land and sea platforms. Ocean platforms are essential for missions needing maximum performance like Mars or heavy geostationary payloads. Modified oil rigs or custom vessels will serve as landing pads and processing centers, handling the sheer size of Starship and Super Heavy. This dual approach, land and sea recovery, lets SpaceX tailor each mission for speed or payload. Routine launches might use Mechazilla for quick turnaround, while high-stakes missions leverage ocean landings for extra performance. This flexibility is key to serving a wide range of customers and missions, from Starlink to interplanetary travel. The filings are the first step in making this vision a reality. Starship's mission is to make humanity multiplanetary, requiring hundreds or thousands of launches per year. Achieving this means rockets must be recovered, refueled, and relaunched in hours, not weeks. Rapid reusability is non-negotiable. Every minute spent on recovery slows the launch schedule. Drone ship landings are vital for high-performance missions that can't return to the launch site. Ocean platforms keep the rapid reuse model intact, even for demanding flights. Imagine starships launching daily from Texas, Florida, or floating spaceports worldwide. A global network of ocean platforms enables recovery from any orbital inclination. This infrastructure is essential for scaling up to SpaceX's ambitious goals. The high launch cadence drives everything. Robust sea landing capability makes it possible. Starship's future depends on this global, flexible recovery system. Starship's recovery strategy has two paths: Mechazilla's launch tower arms and ocean platforms. Mechazilla enables the fastest turnaround, catching boosters right at the pad, ready for rapid relaunch. But this requires extra fuel for the return, reducing payload for high-energy missions. Ocean landings solve this. Boosters use nearly all their fuel for ascent, then land downrange on a floating platform. This maximizes payload without sacrificing reusability. The two methods are complementary: Mechazilla for speed, ocean landings for performance. Routine missions use the tower, flagship or deep space flights use the sea. This dual system gives SpaceX unmatched flexibility for any mission. Landing at sea boosts payload, no need to save fuel for a long return. More mass to orbit means bigger satellites, more lunar cargo, and faster Mars trips. Ocean landings are safer. A miss on a huge platform is less risky than missing the launch tower. The ocean is gentler on rockets, reducing wear and tear. Flexibility is huge. Platforms can be positioned for any orbit, from polar to equatorial. This untethers launches from geography, enabling new mission profiles, even point-to-point Earth travel. Ocean landings also de-risk development. SpaceX can perfect landings at sea before attempting the precise Mechazilla catch. Falcon 9 followed this path, and Starship is doing the same. The first Super Heavy soft landing in the Gulf of Mexico proved the concept. Each step builds confidence for the next leap. Starship's scale brings new challenges. Super Heavy is far larger than Falcon 9. Ocean platforms must be bigger, more stable, and able to hold position in rough seas. Towing a massive booster home requires new logistics and specialized vessels. The booster needs robust, lightweight landing legs. No small feat for such a giant rocket. International law adds complexity. Operating in global waters means navigating regulations and securing permissions. SpaceX must coordinate with nations and maritime authorities to avoid conflicts and ensure safety. The roadmap is clear. First, soft ocean landings. Next, landings on simple platforms, then advanced semi-submersible platforms. Full global deployment will take years, but each step transforms spaceflight. Starship's ocean landings are set to redefine what's possible, one splashdown at a time.